Radi, radi. Ok, ljudi, krenut ćemo, daćemo još malo vremena ljudima da se okupe. Za neki 5 minuta, maks 6, krećemo kako se zove sa uvodom i u 45 kreće prvi govor od Marka Knezevića iz Nordeusa, a onda ćemo imati mogućnost slušamo Alana Hemborija iz Beča i Tomislava Križana iz Zagreba. Tako da, hvala vam puno što ste došli, sačekat ćemo još 5 minuta ljudi da se okupe.
Ovo je nezavisno.
1, 2, 3, 4, ok, može.
Ok? Prošlo 7 minuta. Prvo bih htio svima se zahvalim što ste došli. Zaista nam je drago da vidim kako se zove prvi meetup internacionalni, da smo se kupili u ovolikom broju. Verujem da će ovaj broj rasti kako bude rastu broj meetupa. Za početak bih htio da se predstavim i da predstavim ko organizuje ovaj meetup. Moje ime je Aleksandar Đorđević, ja sam predsjednik upravnog odbora Instituta savremenih nauka, za koje verovatno i niste čuli. U principu, ono što ste čuli verovatno jeste Data Science konferencija, Data Science Conference koju organizujemo svake godine. Upravo institut je jedan od, hajde da kažemo, pokretača čitave priče, ne mogu kažem još uvijek osnivača, jer zvanično nije osnovano, Data Science Alliance-a. Šta je Data Science Alliance? Data Science Alliance predstavlja internacionalnu mrežu community-a koje radi u oblasti Data Science-a. Krenuli smo da pričamo o formiranju same mreže pre 2 godine na konferenciji u Beogradu i samim tim smo došli do ideje i nekako smo vidjeli da postoji prostor i postoji potreba da postoji saradnja između data scientista, ne samo u okviru jedne države, jednog grada, već u okviru, kako se zove, na nivou čitave Evrope, a nadamo se kasnije i sveta. Ono što je dodatno bih htio da kažem jeste da trenutno Data Science Alliance okuplja preko 15 zajednica iz 15 država Evrope i taj broj će, nadamo se kako vreme bude teklo, da sve više i više raste. Neki naš plan jeste da pokušamo dođemo do 30 zajednica iz 30 država Evrope do konferencije u Beogradu, gde bi se zvanično u Beogradu i osnovala ta organizacija. Kao što sam rekao, dolazim iz Instituta savremenih nauka, samo par reči o nama. A pre toga, kako se zove, bih htio da kažem što se tiče samih postavljanja pitanja, da objasnim sekund, to je prvi slajd, jeste kako će se postavljati pitanja s obzirom da imamo internacionalni meetup, to znači će imati jedno predavanje ovdje iz Beograda, Marko Knezevic iz Nordeusa, i 2 predavanja će biti iz 2 grada Evrope drugi grad je Beč, Alan Hemborić će držati predavanje o korišćenju primjeni mašinskog učenja u biomedicini i posle toga će Tomislav Križan iz Zagreba pričati o tome kako možemo da koristimo AI u fintech sektoru. Kako postavljate pitanja? Tako što imate novu aplikaciju Slido, imaćete u uglu dole, kako se zove, da vas podsjeti u svakom trenutku i koristite hashtag DSC Meetup. Već ćete vidjeti, hashtag je već unapred uključen, tako da ne kucate hashtag, nego samo jedan hashtag koji je već tamo. Tako da proverite, uđite na aplikaciju, veoma dobra aplikacija za postavljanje pitanja i na kraju ćemo preko te aplikacije, pitanja koje su najviše upvotovana će dobiti postavljanje pitanja. Nešto malo više o nama jeste Data Science konferencija koju ste verovatno čuli. Ove godine će se držati 920. novembra u hotelu Hyatt Belgrade Regency. Šta je ove godine zanimljivo? Zanimljivo ćemo imati 10 trekova, ukupno 66 govora, 1000 učesnika očekujemo ove godine. I ono što je zanimljiva stvar jeste, mi zaista verujemo da konferencija treba da bude tehničkog karaktera, stoga da sa svaku kartu koju budete uzeli dobit ćete mogućnost da slušate najmanje jedan tehnički tutorial. Što je zaista super stvar i nekako generalno stvari instituta gde ćemo se više fokusirati u narednom periodu i kroz konferenciju, pored podizanja kvaliteta programa, jeste pružanje edukacije. Drugi projekat na kojima radimo, verovatno ste možda neki od vas i čuli za Telesignov dataton, organizovali smo ga bili kako se zove, u početku marta. Ono što jeste bitna stvar jeste, kako se zove, da je drugi neki kolosek gde institut radi jeste organizacija datatona i u narednom periodu nas očekuju još 2 datatona koje ćemo organizovati. Jedan će biti, kako se zove, u sklopu konferencije Think Southeast, a drugi će biti u sklopu, kako se zove, internacionalni dataton gde će se data scientisti iz više od 5 gradova Evrope boriti za nagradu 10.000 evra. O tome možete više, kako se zove, na našim kanalima. I treći, kao što sam rekao, poslednji stream jeste Data Bootcamp, gde ćemo uz narednom periodu raditi kurseve iz oblasti Data Science-a kako bismo zaista približili struku ljudima. I da vas ne bi više zadržavao, kako se zove, pošto niste došli mene da slušate, pustio bi kolegi Marku iz Nordeusa reč, da se ukratko predstavi Nordeus i da htio bi da proglasimo ovaj internacionalni meetup otvoreni. Hvala puno.
Hvala, Aleksandre. Može kliker? Sjaj, hvala. Hello everyone, my name is Marko and I come from Nordeus. And today I'm going to share with you one success story of how we managed to meet user expectations and to provide them with even more meaningful content. So, before I start, I'm going to tell you a few words about who we are. I work at Nordeus, which was founded back in 2010. And currently we have two globally launched games, Top 11, which is Football Manager, and Golden Boot. Besides these two games, we have one in soft launch. It's Heroic Magic Duel. Our new amazing headquarters is in Belgrade. Welcome. And I work together with 170 people from 20 different nationalities. So when you type recommender systems on internet, you may get like a lot of different definitions. Some of them might sound like those are subclass of information filtering systems that seek to predict some preferences or ratings that some user would give on particular item. But I like this one most. It's simple and tells exactly what these systems are. They're systems that help users discover items they may like. Recommender systems are currently mainstay of modern data science since they cover a lot of use cases. Some of them are movie recommendations, song recommendations, shopping suggestions like some on Amazon, detecting host preferences, and so on. But as one of the definitions of data science is that it lies in intersection of statistics, machine learning, software engineering, and domain knowledge, the same applies to recommender systems as they are being one of true data science problems. In order to create one very good recommender system, you need to have all these skills, as we will see. When we talk about recommendation paradigmas, they can be 2 to 20, depending on who you ask, but distinction between these approaches is mostly academical than practical, since in practice you often go for one hybrid approach where you take good ideas for several approaches and apply to your domain. But we need just to mention a few approaches. It's collaborative filtering, content filtering, social filtering, and collaborative filtering can be graph-based, it can be neighborhood-based, and neighborhood-based can be both memory and model-based, where memory can be user-based and item-based. These are just some of the approaches. There are many, many more. I will focus on collaborative filtering for just a few slides. So if you want to predict or to recommend some user particular item, you want to know whether he will like it. And in order to figure that out, maybe the best way, or one of the ways, is to find similar users, similar based on their preferences, some features that you collected, and then figure out whether they like that same item. So two things you have to tackle. One thing is that you need to pick what these features are based on which you're going to find similar users. We call them also neighbors. And to define what will be your similarity measure, whether it's going to be Pearson correlation, cosine, distance, Euclidean distance, or something else. So this is just intuition behind collaborative filters, and I'll just talk now about two separate approaches. One is model-based, where you load entire data set or database in memory, and then repeat the previous steps. So find similar users, calculate similarity measures, see their preferences, and weight these preferences based on how similar they are to your user that you want to give a recommendation. But model-based approach has this pros where he tries to collapse whole database into one model and thus fit memory better in that way, and it's likely to be much faster. And also, it is easier to try to avoid overfitting, since these methods that focus on avoiding it are integrated in model building approach. But what can be bad about model-based approach? It's inflexible, which means if you add more data, you have to retrain your model. And the second one is quality of prediction, but with the recent advancements in model building, there shows that this model-based is sometimes even better than memory-based. So back to our use case. Let me give you a bit more context. Top 11. Top 11 is football manager game where you manage your squad, your players. You can buy those players from different sources. One of them is auction, so you bid for the player you want to buy. The other is scout list, where you are offered some players and you choose which one you want to buy. And third source is this recommendation feature, which once in a week for each user tells him, okay, I found these players for you. They have these stats, for example, they're of this age, they are this quality, they cost this much, you have discount for some currency on them, and they are on this position, which is striker, defensive, goalie, or whatever. So we had a hypothesis that this role is one of the key factors that makes you decide whether you need this actual player or not. So previously, there was a rule-based system which decided what roles, like striker, goalie, or defensive midfielder, will be offered to you. So we thought, okay, let's maybe try to replace this system with some machine learning model that can predict what is the most likely position that you will want to buy in your squad. And why we thought that it might be a good idea? Because we received a lot of feedback on that feature, saying, okay, this recommended player feature recommends me, I don't need those players. Or I was recommended position X and I don't use it in my formation at all. Or I already have like 5 strikers, why would need one more? So we define our basic approach. We gathered all relevant data. So we examined some user reports, some comments, and so we thought of everything that might influence your decision to buy a specific player or specific role. So some of these features were formation, position needed, player purchase history, so position quality, all this in position, when you bought last player, and so on and so on. So we tried to capture like some behavior, previous behavior, and what your current state of your squad is, and so on. So then we follow like best practices for training models. We do feature engineering, feature selection, model selection, hyperparameter tuning, and so on. And we decided to go with some assembly classifier and to use one versus rest classifier. And so as we went with our approach, we encountered a lot of challenges. Some of these challenges, one of the well-known challenge in recommender systems is cold start. That's a point when you need to recommend some player or some new content, and you don't have any data about that content, how it relates to previous items. Or in our case, when you have new user for which you don't have any data. So that was the cold start. The next thing was we gathered a lot of features. So since many things can influence your decision to buy player or not, and thus we had like high dimensionality problem, which was not that big of a problem since we had a lot of data from previous users. And then there was a little bit bigger problem, which was class imbalance. So players tend to buy strikers much more than other roles, and they favor, for example, midfielders over defensive players. But this imbalance was not only due to demand; it was also due to offer, because our offer to them was a bit imbalanced. And this challenge, it's my favorite. It's owning content and playing games are implicit signals of player affinity. In other words, this means that correlation is not causation, because sometimes players leave some data behind them, and we implicit trying to detect whether that player likes that position or not, but sometimes it's not the case. For example, maybe he bought some player because it was a good offer at that moment. It cost few in-game currencies compared to how much it usually costs. He bought it on auctions and so on, and he doesn't even need that role in his current squad formation. So in order to remove this noise, we had to do something. So this was a challenge. And last but not the least, we needed to validate our initial hypothesis that machine learning model was the better choice than rule-based system. So how we tackled these challenges? The first one was quite easy. So we used what we already had. It was a rule-based system that helped us overcome this cold start. So we used that for the newly registered users, and it was a decent fail-safe on our machine learning model. Also, we did heavy feature engineering, so we removed all these features that were redundant by examining correlation matrices, and then we detect what features have more influence than others and remove those that don't have any influence on model accuracy. Also relied on user research reports for that. Also, in order to fix class imbalance, we examined several approaches, but we stick to undersampling because it fitted our use case very well. And this challenging one, so in order to tackle this noise, we try to focus on purchases that really mattered in order to detect what particular users want at specific moment. So we focus on purchases that cost more in-game currencies because we thought it was less likely to do something at random or not optimally when there are a lot of currencies in stake. And at the end, we did our value estimation by using A/B test. So let's see the result. In this graph, we can see report from A/B test. This line says when A/B test started. Those on the left side are two groups, green and orange, which say that everything was in these two groups the same before we started A/B testing. And at the start of A/B test, at some servers, we deployed our new machine learning algorithm with marked with the green line, and on others there was rule-based. So immediately we saw uplift in players bought, and the lower part of the graph you can see the percent difference was around 0 before the A/B test start, and once the A/B test start, on average, let's say there were like 30% uplift in purchases of these recommended players bought. But this report is a bit tricky. Here's why. Because once we give users better source of buying players, they might buy less on other sources. As I said at the beginning, we had 2 more auctions and scout lists where they can search for players they might like. So in order to be sure that we made a success, we had to follow different metrics as well. And at time, metric that was relevant for us was average revenue per daily active user. Since we saw uplift in that as well, of course not in this scale, we decided that this was success. But what really brought us joy is user comments. This was particularly important for us because we didn't announce that this was new update because it was done only on servers. It was not like officially announced, but users still figured it out. They noticed that something better in the game, and they welcome that on our forums. To conclude, so giving users meaningful content is rewarding in both ways. And if I want you to take something from this talk, it will be next 2 points. So implicit signals of players' affinity may affect accuracy if not taken with care. So be careful since we don't have labeled data set, okay, this thing user likes, this doesn't like, and so on, we try to devise that from data we have. So be careful when doing that, just not to mistaken correlation with causation. And last, falsely selected measure of success can mask out failure. So we don't, if we only focused on this report we just saw, we would think, okay, we increased something like 30%, but it was not our measure of success. And finally, food for thought. This is some of recent posts by Lex Friedman. So he says that algorithms that recommend and made up by Twitter, Facebook, YouTube, LinkedIn are the most powerful forces influencing the future of our civilization. We can see that. But we can build these machine learning models well, but it requires an open mind to hear all, not just the loud few at the extremes. Thank you very much. I'm open for questions. Please shoot.
Thank you, Marko, so much for inspiring talk, and thank you for bringing us a bit closer into this world of recommender system in the gaming industry. We have a few questions on the slide. So I will remind you again that you can ask a question using the Slido application. The code is, as we say, DS meetup. So basically, it's very easy. It's good for using, and that's how we're gonna have an opportunity to listen from a question not only from Belgrade, but also in the same time from Zagreb and from Vienna. The most upvoted question is there anything you use for recommender system which is only specific for gaming industry?
Mm-hmm. Well, specific can be like data and history data that we have that can describe player behavior.
Maybe like I can use like a bit of time to just maybe say, is there any kind of algorithm that you use that you saw that it is giving much better results inside of your industry that you can say, okay.
So we didn't devise any particular new algorithm to use it. We just take special care with our domain knowledge to feature engineer to get the features that would mean the most for the model.
Okay, thank you. Second question is, what do you think should be a first thing starting with a recommender system?
Can you please repeat?
Yeah. What do you think should be a first thing or a first step when you start using recommender system? There's something you can advise for the people who are just starting this field.
For just starting this field, I think you have to find the problem that you're passionate about, you want to solve, and start with the small steps. I would recommend just at the beginning using some rule-based system and then advance with more complicated stuff, just to have like a way to iterate and see how much you progress. That will, for me, be like a good way to start.
Okay, thank you. The next question is, I think this is for Nordeus, not only you, but do you have a self-developed DS pipeline or use an open source / market solution?
I think we develop most of our stuff by ourselves, and yeah, that's it.
Okay, thank you. The next one is, did the feature dictate the creation of the collaborative filter, or did the content you tried to push toward users dictate the direction of feature creation?
So for feature creation, we relied mostly on data we had and did a lot of exploratory analysis on the data. But what was also very relevant for us was what users told us on our user research sessions about how they select or how they decide which player they will buy or not.
This one is a bit outside of the recommender system, but I will say it. Did you try to do text sentiment for comments, perhaps, to see?
Yes, we had also that type of project in Nordeus.
Okay, let's see. We have like a few more minutes for questions. Did you consider any other criteria except average revenue per player?
We explored a lot of metrics just to see that we didn't break something. For example, retention was particularly important for us. But for the presentation's sake, I only focused on these two metrics that I show you.
Okay, I think this is a connected question, so I will go forward with that. How do you decide which parameters are the best in your recommending system? What is the key parameter, perhaps, your?
Well, since we had a imbalanced data set, we focused on F1 score besides accuracy after we did undersampling, and that's it.
Okay, two more questions and we are done with the questions. Just a second. How do you handle implicit signals, or how do you determine cause of player's purchase?
Okay, well, besides using these machine learning models, we are aware of some causal models, and we try to apply them in order to detect what's really causing some purchases, but it can be done to a certain limit. It's not like silver bullet to solve all our questions and to see what causes what.
Okay, thank you. And the last question is, did the feature dictate the creation of the collaborative filter, or did the content you try to push toward users dictate the direction of feature creation?
I think there's a bit of both.
Okay, thank you so much for these answers. Can we have one more round of applause for Marko?
Thank you very much.
Okay, thank you so much. Now we're going to have a short break before we start with the second talk. It will be Alan Hambury from Vienna. I will use this opportunity to wave to the people from Vienna who are listening to us right now. We are going to listen to them very shortly, and I will just call you. I will just tell you that you can use some press, whatever you want for it or to drink. Between this small coffee break. Thank you.
just do it. Yeah. Do I start now or 5 minutes? I think so. Yeah, let me check.
Based on the agenda, in 5 minutes.
Okay. Okay, then let's just ask them on Slack if they are ready.
Yeah.
Okay, Alan, I think they can start.
Okay.
So good evening, everybody. I'm very happy to be here, and I'm talking about exploiting data in medicine. So this is work that I've done at various places that I work at. So first I'm going to tell you about how knowledge is gained in medicine today. So medicine, like many other scientists, people do experiments and they publish papers describing experimental results, and lots of these papers are published. So I have a graph over there showing the number of papers that are indexed in PubMed starting in 1950 and going up to 2018. So in 1950 there were about 100,000 papers published in the medical area. Last year, over 1.3 million. Now, many of these papers don't have anything to do with human medicine. So there are a lot in there, for example, about mice. So sometimes this gets confusing, especially for journalists who are writing for magazines and newspapers. So you might find an article like that says, this diet is not effective, it causes blood sugar problems in women. What they don't point out there is the experiments were done on mice. So actually that should be causes blood sugar problems in female mice. This doesn't make the same impact. But anyway, there's a Twitter account that always tweets for articles like that in mice. Okay, so once you've taken out the papers that are about mice, about zebrafish, about fruit flies, about all the others, you're left with what actually applies directly to medicine in humans. And those generally happen to be in the form of clinical trials. So that's a sort of typical clinical trial publication where they've taken people who have hepatitis B, they tried 2 treatments on them. One of them has to do with a standard hepatitis B treatment, and for the other one, they give them additional injections of some Chinese medicine herb. And they did that on 120 people, 60 with the old method, 60 with the new method. So the problem with that, of course, is 120 people are not very many. So what also happens is, generally there are lots of these clinical trials done around, and then they want to know, okay, so how can we get more statistically significant results? And for that, there is a process called systematic reviewing. So that's what a systematic review looks like. And basically what the authors of this do is they find all the papers that have to do with this particular Chinese herb and hepatitis B. So they found papers describing 35 clinical trials with 3,500 participants. So you see sort of 100 participants per clinical trial, so not very many. But then if you put them all together and reanalyze the data, so do some statistical analysis, you sort of get results on 3,500 participants, which are statistically more significant. Now, a question about this is, how long do you think it takes to write such a systematic review? So from the time when the review is registered, so people decide to do it, until the paper is published. So shout out some numbers in weeks, on average.
2, 12, 50, 20.
67.3. So that was another study done on 192 systematic reviews. So it means it takes about 1.3 years